This is a tutorial on the model of the atom and its overall structure. By the end of this tutorial, you should be able to recall the structure of the atom and know what it is made up of. You should also be able to describe the relative size of the nucleus. And what we mean by relative is when we compare one size of one thing to another. You should also be able to show what the atomic number is and the mass number of an element and how to calculate them. In order to get the best from this, you will need to have a pen and paper to hand to write things down and access to a periodic table, either in your planner or one on the internet.
Yeah, Steph, there's plenty of space for where you're going to put this one on the top. You'll see this little speaker. Just delete it and stick your own in with the words I suggest on the bottom.
Before we get started, let's see what you already know with this true and false quiz. Atoms cannot be split up into anything smaller. Atoms are solid objects and nothing can pass through them. There are millions of different kinds of atoms. No one has ever seen an atom. Write down true or false for each answer. Once you've done that, press the space bar to reveal the answer. What's an atom made of? Oh, atoms are extremely small, and everything you can see, including yourself, is made from atoms. Now, atoms themselves are made up of 3 subatomic particles. Subatomic is just another way of saying something smaller than an atom. Draw the picture and label it using the words in bold in the word box. When you've finished, press the space bar to reveal the answers. Give yourself a score out of 5. And if you want to, have a competition with your friends to see who can get the most. Now don't worry if you make a mistake. Come back tomorrow and try again. You'll be surprised how much you can remember. How did you get on? Now that we understand what an atom is made of, let's look at what fits that where in its structure. At the centre of the nucleus, the atom has a positive charge. The nucleus is made up of protons, which are positive, and neutrons, which have a 0 or neutral charge. They both have a relative mass of 1. And the atom itself is made up of mostly empty space. So, if an atom was the size of a school hall, then the nucleus would be the size of just a single grain of sand. Now, a nucleus is surrounded by negative electrons. They have a relative mass of 1/2000, which basically means if you took 1 proton or 1 neutron, you would have to have 2000 electrons for it to weigh the same mass. So, we generally ignore the mass of an electron because it doesn't weigh anything. Now, these electrons, even though they don't weigh anything, are incredibly important. They're not in the nucleus. They are arranged in layers or shells, and we call them energy levels. Now that you've got some information about the mass and the charge of each of the particles found in an atom, see if you can complete this table. So copy and complete this onto your blank sheet. If you can't remember anything, pause this and go back through the presentation to find the information to help you. When you're ready to move on, press the space bar. Now, scientists have so far identified approximately 118 different types of atoms. That means there's approximately 118 different types of elements, not just on planet Earth, but in the entire universe. Each element has a fixed number of protons. That means that proton number never changes, and as we've just discovered, the protons are always found in the nucleus. Let's look at the lithium atom on the periodic table. You'll find it, for ease of access, on the left-hand side. Lithium looks like this. The chemical symbol is made up of two letters. Whenever you get two letters, the second letter is always a small one. All chemical symbols on the periodic table start with a capital letter. Have a look now to check. So, lithium. If you notice, it's got two numbers on there. A small one and a big one. This small one here is the atomic number, and it's sometimes referred to as the proton number because it tells you how many protons make up that element. So, if you were given a random atom and you found out that it had 3 protons in it, you would know straight away it must be a lithium atom, because only lithium atoms have 3 protons. The higher number of the two is the total mass, which is why we call it the mass number. This is made up of both protons and neutrons. You can have a look at chemical symbols on periodic tables to work out the numbers of protons and neutrons in every single element. Here is the symbol for the element phosphorus. Use the information on the slide and previous slides to work out how many protons and neutrons a phosphorus atom has. The answer is on the next slide. So, phosphorus has 15 protons. So 15 is the atomic number. Its total mass is 31. So that's the total number of protons and neutrons in the nucleus. So how do we work out the neutrons? Well, you take away the protons away from the total and you're left with just the neutrons. So you simply do 31 minus 15. The answer is 16, so there must be 16 neutrons in a phosphorus atom. Have a look now at other atoms on the periodic table and see if you can work out how many neutrons they have. Let's have a look now at these atoms. So, using the chemical symbols, write down the number of protons and the number of neutrons in each of the following. Once you've done that, consider this question. Potassium, with the element K, has 19 protons and 20 neutrons in its nucleus. So what would be its mass number and its atomic number? Right. Oxygen has 8 protons and 8 neutrons. Now, just because you've got the same number as neutrons as protons in this particular element, it doesn't always follow that every element has the same. Here's sodium, for instance. That has 11 protons, but 12 neutrons, so you need to be careful. The second question was, the chemical symbol for potassium should look like this. So we can see that potassium has 19 protons, which is the atomic number or proton number, and it has 20 neutrons, making a total of 39, and the number 39 is your mass number. Let's see how much you've learned. On your piece of paper, copy and complete the sentence below and fill in the blanks. Atoms contain a nucleus with a blank charge, surrounded by blank in shells. The size of the nucleus is much blank than the overall size of the atom. When you're ready, press the spacebar to reveal the answers. Now that you've completed the PowerPoint, you can have a go at the questions in the Educake.